order to log in to get access to the InfyTQ portal. Then the steps was we need to log in here as I'm a user, so my credentials are available in InfyTQ. So that's the reason why it was taking up. So there are a lot of modules where you need to work. That is database management system, part 1, part 2, Java 1, Java 2, in the Python 1, Python 2, and data structures. So this is the syllabus what you need to prepare before you are going to take up the exam from 6th to 10th Feb. So let us check with the very first module, and that is the DBMS module. So in this DBMS module, we will be having the interface at this model. So when we are looking at this interface model, so we need to click at the start button. So this is what introductory page, the content page, course content page, and we will be getting the introduction. We'll be getting the introduction. Fine. This is the navigation part. Once the navigation part you're familiar, it won't be a much difference for you to get into the content. So the introductory part we will be now starting up. So this is what my intention was, to bring you the content. So as part as database management system, it looks, the very first ingredient will be with the data, and then it will be with the information, and then it is going to move up with the extracting of the knowledge. So these three things will be the primitives of the content. So the traditional example of what we call data was, it is purely raw until unless 2 or more content is going to be brought together, then only it is going to say it moves up to the word called as an interface. It moves up to the word called as information. So in such a scenario, one second. In such a scenario, so the very first word we are going to call here as data, which it is going to have collection of information, and this collection of information needs to be processed, where we are going to get the word called as an information. Once the information has been taken up, the next thing was we will look to extract to make decision making, which we are going to call that word here as a knowledge. So in the terms of a software application, the most important thing content which we need to figure out will be the word called as an integrity. So a equivalent a description towards integrity for our quick understanding was whatever data we are going to give, that should be very accurate. So this is what we are going to have as an interface definition, followed by the next word will be the availability. So when we are going to call this one as an availability, the thing was it round the clock 24 hours data should be available. That is the second feature. Third thing, we have security privileges with user IDs and passwords. Those are all linked to the security aspect. And fourth thing was the application what we are going to develop, that it is going to be independent. Means it can work with iOS, it can work with Microsoft Windows or Ubuntu, etc. And finally, we need to parallel processing, that is simultaneous access, where this is going to move up with the word called as a concurrency. So the conventional way of bringing the things what we are going to it is going to be a two-dimensional data, which it is going to be stored in a notepad or a text pad. So this is what a flat file. So this was the earlier usage in the file-based system, and this file-based system has been migrated to the relational database management system. So that was the drawback when 1940s, 50s, when there was the first generation computer. Then a file system was there, COBOL was there, Fortran was there. So using those softwares, they used to process the data. But when the database management system came into existence, all those such primitives has been winded off, and the new concept of database management system has been introduced. So why we are going to use this database management system? Because we are going to make a definition. We will create tables, we will maintain the tables, we will maintain concurrent or parallel access so that any end user can simultaneously use. So where is this DBMS looking up? Means it is going to look up over the operating system. So the first internal content will be the operating system. Above it, the next layer will be the database management system. And then the database management system via the applications such as SQL, MySQL, or SQL Server or NoSQL. With any of an application, it is going to link up to the users. So this is all regarding a prospection of how DBMS is going to manage the things. So what will be the different functionalities of working with the DBMS? The very functionality was data management. That DBMS, it is going to store, it is going to retrieve, and it is going to modify the data. Followed by it supports transaction support. So right from begin of a transaction to end of a transaction, it should be there. If anything is going to be violated, ACID, that is ACID properties, that is 1, we call it as atomicity, 2, concurrency, 3, isolation, and 4, durability. So any of a property is going to be lost, the transaction will not be looked upon. So that is where the one of a feature DBMS is going to support. Then we need to have multiple users can share concurrently, access the files concurrently. For that, we are going to use this concurrency control. Then the another feature was we use two-page locking, and we use ARES algorithm. There we will be using undo phase, redo phase. So that all aspects we are going to call it as recovery, followed by giving read privilege, write privilege, protection, security, user ID, passwords. So that is all dealt with the security aspect. And the other thing was at any point of time, data at one end or data at another end should be same. So where we are going to say this integrity is going to be maintained. And finally, it is going to support importing, exporting, backing up stories, making up log So who as accessing the database, etc. All those aspects, it is going to treat it as a utility content. So these are some of the primitives where this DBMS is going to support. And after that, what type of DBMS are going to be there, etc. So if such is a case is going to happen, so you can see here DBMS is categorized into these forms. One, we are going to say it is hierarchical. Two, we call it as NoSQL. Three, with network database management system, and mostly the relational database management system. So every setup has its own pros and own cons. So coming to the architecture of a hierarchical, so this is what we can say, it is organized into levels. So one, we can say professor, two, we can call it as an associate professor, and three, we are going to call it as an assistant professor. So we are organizing the faculty in three levels: professor, associate professor, and assistant professor. So this is where we are doing it in a folded approach. We call that one as a tree structure, where we call that content as a hierarchical content. And next one, we are going to represent the content in form of graphs, in form of trees, which we are going to call that architecture with the network DBMS. And third thing, we are going to associate mostly the things in form of rows and columns. So associating the things in form of rows and columns, we are going to put more focus to this course. We will be saying that it is a relational database management system. So we call it as tuples, attributes, which I will be discussing in the next slide. And the last one was, if we are going to work with unstructured data, so that means whatever content we are putting in tabular form and using, we call those elements as a structured format. But when we are working on Twitter tweets, when we are working on YouTube comments, when we want to analyze the posts on Facebook and such type of social media platforms, then we, instead of using the structured approach provided by hierarchical, network, and relational, the option was we need to go with a software called as NoSQL. So in NoSQL, it is going to store the primitive in form of key value pairs. So in advanced programming like R and Python, we have the dictionary data type, where we are going to put the things in key value pair. So in the same pattern, we are going to bring the Twitter tweets, the Facebook tweets, etc. into NoSQL, and thereby we are going to analyze and retrieve the data. So this is how a NoSQL is going to use for unstructured content. So this is the holistic view. After that, the very first content which we are going to focus mostly will be the tabular approach. That is what we are going to call it as a relational database management system. So you can see at this point of time, there is a table which we are going to call it as an employee, and it contains ID, employee name, salary, bonus, and department. So you can assume that there are 4 rows and 1, 2, 3, 4, 5 columns. So 5 4s are 20 elements we are going to put into this things. So the next thing, what we need to discuss here was, what is an attribute and what is a tuple and what is a row. So you can see here, 1 followed by James Potter, salary was 75,000 bucks, and his bonus was 1,000, and he works for a department called as ICP. So this entire thing we are going to call here as a row. So this we call here as a tuple. The next thing, ID is assumed as a column, ID is assumed as an attribute. This was an acronym. Similarly, we call this one as e-name, which we are going to assume it as an attribute, column, or a feed. So as I mentioned, the acronyms will be for a row, will be a record, or will be a tuple. The next thing we need to understand, and mostly InfyTQ at this point of time in objective questions, they will look at the word called as cardinality.
So a table will be given up and they will ask you what was the cardinality. So cardinality, implicitly it says that how many number of records, how many number of rows are available at that point of time. So here I'm going to have 4 rows, 4 tuples here. Therefore, the cardinality of a relation which we are going to show here will be at 4. So this is how we are going to measure the cardinality content. So what I have talked at this point of time mostly was we were talking about a table here. Table consists of rows and columns. And when we are going to say it is rows and columns, columns acronyms are attributes and fields, and table acronyms are going to be the row attributes will be the records or tuples, and the number of rows we need to measure. So those we are going to put this as degree. As we are going to call here as a, 1 second.
Cardinality.
Cardinality. It is going to be called as a cardinality. So 1, 2, 3, 4, you can see here the word called as a cardinality. And the interesting part here was degree. So I just missed this word. So how many number of attributes are going to be there? Those number of attributes, 1 ID, 2 e-name, 3 salary, bonus, department. So I do have 5 fields, 5 attributes. So that is where I'm going to measure up the degree here. So this is how the first model what we can use. The next thing emphasis which we need to look will be the words called as primary key content, and followed by some foreign key contents, and followed by some data types, checking of attributes, etc. So at this point of time, to maintain accuracy, to maintain integrity, so what will be the key elements means the key elements will be the keys, that is a primary key or a foreign key, etc. So at this point of time, when I'm going to put this as a column here, and then I want to identify CSE students. So I can say 19B0, 1A0, 5XX. So 05, the 4th position and 5th position. The 4th position and 5th position, it says 05. So when I'm going to say 05, the column itself states that it is a CSE students. When I'm going to show it is 1, 2, it shows that it is going to be an IT students. Similarly, when the column is going to be represented as 04, then it is implicitly showing it as an ECE students. Therefore, what is a domain here means the values between 0, 1 to 15. So whatever courses are there, a number is going to be assigned. And if that number is present at that point of time, where we are going to check that constraint as a domain constraint. Let us say that I have a blood group A, B, C. Let us say we have a mark list, the 3-2 mark list or a 3-1 mark list. And we are going to give grades, O grade, A grade, A plus grade, B grade, C grade. There is no S grade, there is no X grade, there is no Y grade, because we have fixed the domain. What is the domain? O, A, B, C, A plus, etc. We have given only 5 values. So whatever value we need to fill into that, only according to those values only it has to be there, where we are going to call that as checking of a domain. And next thing was, at any point of time, the field should not be empty. We call such situation as not null. The second element what we are going to put was, once there is a prime attribute, that prime attribute should be unique and it should be different from others. So in the entire world or in the entire organization, one key should be unique, and that it is going to be a key differentiator, which we are going to use a word called as a primary key. So every table do refer to the word called as a primary key. Now I do have table 1, I do have table 2. Now I need to link table 1 with table 2. At that case, I'm going to use the concept called as a foreign key. So when I want to make a relationship establishment between table 1 and table 2, at that case, we are going to opt for a table called as a foreign key. So let us see this example here. before we take up the example, we have discussed about one primary key, which we call it as unique and not null. Next one, we talked about referential key. The other name of a referential key, we called it as a foreign key. There is one more content. What we need to understand was a candidate key. So when we are going to say it is a candidate key, there are a lot of keys at this table: employee number, Aadhaar, name, date of birth, salary, etc. So I can have 5 and I get combinations 00 to 44. Obviously, I will be getting 16 combinations. So having 16 combinations, we are going to call it as a superset and super key. From that, in order to get uniqueness, in order to get a more precise way of identifying a record, we have to identify with the next level called as a candidate key. So this candidate key should be as minimal as possible for identifying the entire record. So a table is there. There we are going to have 4 fields, and all the 4 fields we are pointing to a record. So in order to identify a record, I need to identify which 2 keys will be used or which single key can be used so that the record can be identified uniquely. Therefore, we need to use a word called as a candidate key, which it is going to say it is a minimal set of the content. Now let us look at this example. I'm going to have an employee ID, that is employee number, Aadhaar number. So employee number, yeah, you can say I am working for this organization in this domain, in this business, in the company called as Infosys. Every person will have only one ID. So that it is 100% valid to treat because it is supplied by the organization. Therefore, to that domain, to that application, employee number will satisfy. Okay, let me see what happens if it is for a Aadhaar card. Okay, for the 138 core corporation, we have Aadhaar cards. Okay, fine. But my company is in Europe, my company is in USA, my company is in UK. Now, will the Aadhaar card content will be applicable to Americans? Will the Aadhaar card will be given to US or Europeans or Chinese, etc.? So it is not possible at that case. Therefore, according to Indian country, yeah, Aadhaar card, you can treat this as a unique. But when it goes to a multilingual content, at that time, Aadhaar card is going to fail. Therefore, again, uniqueness is not coming at this case. So similarly, what if there is a small company, if there is name and date of birth, if we put together, we are going to call that word as a composite key. So when we are integrating 2 keys and getting and retrieving the data, at that case, we call it as composition. For example, if I am going to say Korada is going to be my last name, and Ramchandra Rao is going to be my first name. So if complete name Korada Ramchandra Rao, so I can have first name and last name. So if I am going to visit to a marriage called as Korada, at that time, all the people will have Korada as the surname, and it will be very difficult to call at that time, and all the people will turn to you. So which is not practical at that time. So uniqueness again fails, or compositeness again fails at that case. So we talked about composition, we talked about primary, unique and not null. So what will be the best option was, we need to go with a candidate key and we need to identify which it is going to be a minimal. So if the database is very small, yeah, we can have a composition of employee number and date of birth. But see, again, date of birth, mostly it is unique, but 2 or more fellows have a same date of birth. Again, it is bringing up inconsistency problem. Again, it is going to violate the data integrity problem. Therefore, we need to identify a unique value, and almost every domain will have a primary key. That too, they are going to give it as an employee number. So once we are going to work with a primary key, the most important thing was it should be unique, and it is not going to allow any missing values, any empty cells, so that it is going to be identified, doesn't allow any null values. So this is the key takeaway of bringing up the data integrity and constraint content. The last way of putting data integrity and constraint was using a foreign key. So assume that there are 2 tables here. The first table we are going to call it as a computer, and second table we are going to call it as an employee table. The first table we are going to call it as a master table or a parent table, and another table we are going to call it as child table or a reference table. And I need to join table 1 with table 2. I need to link table 1 with table 2. So at that case, we have to rely on a word called as a primary key to get relationship. And the most important way of putting primary key was whatever key we are going to select from that table, that must be a established key, and that must be a primary key in that table. So that is the reason why you can see here it is given with blue color. So whoever table has a primary key, only that primary key can be navigated to another key. Then only a foreign key constraint can be made. So here you can see here James Potter, he is going to use a computer called as 1001, and Ethan, you can see here he is going to use a computer which is going to be null. So this is where the table is going to not meeting the requirements. The reason was whatever we have asked that it is not going to meet, immediately system it is going to meet null. So why this null came? Because you have learnt join concepts. First join, inner join, second join, we call it as outer join, and 3 we are going to call it as left outer join, right outer join, and full join. So using that join concepts, when two tables has the equivalent data, yeah, data will be brought. If they are not brought, then it is going to bring up the null values. So this is all regarding the data constraint and followed by the keys. So the next exercise, what we are going to take up will be the word called as ER diagrams. The next exercise, what we are going to take will be the ER diagrams here. So quizzes, I recommend you to start today itself. We have 3 quizzes, almost 6 questions at quiz 1. We have 6 questions at quiz 1, quiz 2, and quiz 3. I have the key right now. Even you can surf in Google, that is keys for InfyTQ DBMS module. Yeah, they will come. A person called as Wonkar, he has already given those keys. So you don't rely on external sources. Try to build your self-confidence. You make the key, you make the solutions on your own, and if any difficulty, you can refer to the key. But of course, the keys, in the one we are starting this at this point of time itself, Infosys people, they are going to give the answers here itself. So I will just show you here. So you can even help me in this regard. So I'm poor at putting this quizzes, etc. So I will just give you, let us work on small quiz, easy quiz. So now tell me the, tell me the answer. A record relational database is a collection of tables. Okay. Yeah. Second one, a relationship among the set of values in a table is called as, yeah,
relation.
Tell me. Relation. Fine. Next one, a set of permitted values of an attribute. Domain. Yeah, permitted values, I gave you an example. So CSE is 5, IT is, yeah. Next one was the attribute values that is currently unknown. Yeah, by default, it is given null value. And see here, there was a table called as salesman. He has 3 fields, sales ID, sales location, salesman location, and salesman name. And what is the cardinality here? Yeah, cardinality, it is going to give how many? Yeah, tell me.
Sir,
tell
table is not
table is not available because we need to get number of rows. So it is maybe my internet broadband speed is less. Maybe the table should appear at this case. So
no,
randomly.
Sir, while you are answering also, table is not visible, sir.
Okay. Okay, then again, I think this you can take it up. What is the degree
P,
of the
sir.
relation?
P.
3 because we have SID, yes name and location. We have three, so obviously 3. And if I'm going to submit the answers, do you want to? Yes. And yeah, yes. So what went wrong? Option is correct. Option is incorrect, it seems. So relationship among the set of values in a table is relationship in a set of values. You can go with column here, and this is what it is showing. So again, it is another wrong. Maybe it is attribute. You can just work it out. So in this row, it is row. Okay, fine. So I will take it up with row, and because table is not known, I'm not taking this cardinality value. So 5 correct, 1 incorrect. In this way, show answers. Okay, then we are going to submit this. Fine. In this way, we are going to, you have to complete 3 quizzes. Right now, quiz 1, quiz 2, quiz 3, theoretical part I have done. Now you need to work on the quiz part. So mostly this is the pattern how Infosys is going to ask you. So try to complete as many questions, as many exercises with this. So now let me start the second module. What here it is, the entity relationship diagrams. So today, after completing the ER diagrams, we can stop our lesson. So now let us look at the second module. We are going to call here as ER diagrams. So in this ER diagram, the 2 most important elements will be, 1, we are going to call it as entities, and 2, we are going to call it as attributes. So attributes. So I'm going to have this table name, which we are going to call it as an entity name. And most importantly, what you should understand was, if we are going to put a primary key, definitely you should give an underline here. So primary key for a table is going to be underlined. And the dependent attributes, the employee name, salary, department. So these 3 elements are going to be purely dependent on the primary key. Therefore, such elements we are going to call it as non-primary key attribute. So let me give you one real example. Assume there is a family of 4 members, father, mother, child 1 and child 2. Father is going for earning. So obviously mother, child 1 and two children. Child 1 and child 2. Yeah, thank you. So mother, child 1 and child 2, they are dependent on their father. So similarly, now the earning person we are going to assume here as a primary key, and who are dependents. So the wife, the child 1, the child 2. So these are going to be the dependents on him. So we are going to call such element as a non-key, non-prime attribute. So this gives you a clear understanding for what is the relationship between the attributes in a table. So mostly primary key should be not null and unique, and the other things what we are going to be considered, they should be dependent on the primary key. So this is the takeaway from this slide. Next one, I have table 1 here and I have table 2. So between table 1 and table 2, I need to make a relationship. So this is where a theoretical part orientation goes, which we are going to call it as a relationship. So relationship, we are going to associate one table with another table. So this is how we are going to bring. The previous example, what we have taken was computer and employees. So computer is allocated to an employee. So what type of computer? It is a Dell, it is a Lenovo. What type of model it is? Core i3, Core i5, whatever model it is. So this, we are going to describe the computer, to whom this computer was given. So that is what it is recorded. So if you see my cabin, I had a computer got from my department. So for an employee, a computer was granted. So that will be recorded. So my computer, etc., everything will be recorded at this point. So that is how a relationship between an employee and a computer, we are putting this in a table. The next thing was, for example, there is a CSE department. the head of the department, he works in the CSE department, and the faculty also works in the CSE department. Now you should understand the small thin line, that is, we can say he works in the CSE department and he is managing the CSE department. So he is going to have two roles. So that is where the next level, what we are going to say a relationship works in and followed by manages. So head of the department works in the CSE department. He teaches subjects. He teaches subjects and he belongs to CSE department. Along with that, additionally, he is going to manage the CSE department. So therefore, he is working on two roles. The first role works in and second role we are going to call here as managers. And obviously, when I come to my college at 8 o'clock, I will report to my head of the department. Similarly, head of the department comes to college at 8 o'clock and he has to report to himself, where we are going to call it as self-relation. That is what we call here as a report to relation. So that is what we are going to call it as self-relation. We call it as report to. So this is regarding three types of relations. And most importantly, how relations are going to be taken up. Relations are going to be taken up with one-to-one relation, one-to-many relation, and many-to-many relationship. So in InfyTQ, you will be getting the diagrams and they will be asking you to match. So here you can see many to many, a bubble is there, 3 lines of arrow marks are there. And similarly, if there is a one-to-one relationship, you will be getting a plus symbol at one end and another end. So the diagrams itself has a technicality of representing. That is why we are going to call them as an ER diagrams. Understanding, looking at the diagram itself, we can say whether in the project what you have done in mini projects or main projects, seeing the ER diagrams itself, we will comment you where is the primary key, how did you relate first table and second table. So I am not looking at the data dictionary, I'm just looking at the tables what you have drawn via ER diagrams and suggesting you. So that is where the symbolic representation is going to make its impact. So now you should understand the notations here. Now you should understand the notations, that is the Crufort notation. So you can look at the 4 things, one with exactly 1, either 0 or 1, either 0, 1 or more, and 1 or more. So the ER diagrams questions will appear like this, and they will ask you to identify what type of relationship it is. So there your knowledge has to be taken up. So I have 4 types of matching. So which type of matching I have applied to which table. So that is how you have to give a good juncture at that time. So next thing was, if I am going to have a foreign key again. So foreign key has to be represented in the ER diagram itself. This is where another crucial element which we have to bring up. So you can see here, in one table, I am going to have an employee ID. In another table, I am going to have a computer ID. In one table, ID is going to be primary key, therefore it is underlined, and computer ID is going to be a primary key and it is underlined. Now I am going to make a foreign key relationship and I am going to relate table 1 with table 2. So that is how the diagram it is going to show that for this employee, this computer was allocated. So the relationship between table 1 and table 2, we are going to figure out, which we are going to call here as an allotment. So this is how we take 2 tables, that too they are going to have primary keys, and we are able to establish a relationship between those 2 tables. So enough discussion will happen between 1 to 1, 1 to n, etc. So for interest of time, at 4:20, we are now winding off the session. So the things you should be taking care will be the ER diagrams, mostly right from the InfyTQ modules. The content here, you can go in parallel along with me. So this is how you are going to move to the learning journey, journeys. So I anticipate that you should check up with these elements. So the DBMS, etc., the learning content. So in the learning content, you have this DBMS part 1, part 2. So in DBMS part 1, if you are going to navigate at this point of time, you will be getting contents. Then in this content, what will be the coverage you need to understand. It is up to ER diagrams, it is up to normalization, basic SQL commands. So the basic contents up to DDL, DML and DCL commands, etc. These are going to be operated. SQL, the select command with group by, order by, having, from, where. So all these are going to happen. Similarly, the inner join, the outer join, so Cartesian product, these operations also will be part of this first module. So holistically, in these 4 or 5 days, you need to look both at theoretical part and the quizzes part. So this is where you need to spend much of a time. So, and coming to the second part of the DBMS. Coming to the second part of the DBMS, again, you can look at the content here. So you will be having a query inside a query, nested queries, then inner query communicating the outer query table name directly used in an inner query. Obviously, we are going to call that one as a correlated queries. So such type of querying and subquerying, followed by concurrency control and transaction management, and the transaction management followed by B plus trees, etc., the indexing part. So all these elements along with unstructured data, that is NoSQL. So these are the advanced learning contents what you have to cover out with this DBMS2. So for the February 6th, you need to look at all the modules at this case. So this is all my inputs for today, and I will end up at this moment of time. And if there are any queries regarding these issues, I'm welcome to take up the content.
Sir,
Yeah, tell me please.
are these